Now look at the calculation we have on the screen. We are going to use them to further portray the point on this topic, velocity time graph. Let's go. A body at rest is given an initial uniform acceleration of 8 meters per second for 30 seconds, after which the acceleration is reduced to 5 meters per second square for next 20 seconds. So now let's take it one before the other. This is the velocity time graph. At this point, I'm measuring v with respect to meter per second, and this one is t in time, and this is the origin. Now a body at rest, this is the rest, and then it has a uniform acceleration to this point, and the uniform acceleration is 8 meters per second square. From here to here, let me call this place point A. It started from the origin and moved to this point A. Then for 30 seconds, when they give you time, time is everything on the horizontal axis. You have to bring it down to write 30 seconds. And at this point, there is a given velocity, v. I don't know what that v is. I can call it v1. So because as the car moves from a particular point to another point, it has different things. It has speed, it has time. It has accelerated because it started from the origin and a particular distance has been covered. Then when we got to A, the question said after which the acceleration is reduced. Reducing acceleration, this, no. If you put this, you are wrong. Acceleration is reduced because acceleration is really talking about the slope. When the slope is reduced, it means that the angle with the horizontal has been reduced, and that is by taking it in this direction. Remember, this was the direction it took. Now, when it reduced, it goes to this point. I'm going to give you 5 meters per second square. So this is a reduced acceleration. So when the acceleration is reduced, it continues moving also on the straight line to another point, let's say point B, and at this point, there is a particular speed it got to. So what is the time for the reduced acceleration? After which acceleration is reduced for the next 20 seconds. This is 30. Next 20 means you add 20 to the one you already have. This is, then next 20 means 20 plus 30 is going to be 50. Remember the statement next. All right, that is the first thing they said there on the first statement. It said the body maintains the speed attained for 60 seconds. So from here, continue going to another point, let's say C, for 60 seconds. That means if it takes 60 to move from here to here, then from here to here is going to, from here all the way to this place is going to be adding 60 to 50, which is going to be 110. So what happens? After which it is brought to rest in 20 seconds. So when it got to this point, a brake was applied and the body comes to rest in 20. So this is 130 seconds deceleration. So let me call this place point D. So you see, this is the motion of the body from this point to this point, from here to B. Acceleration was reduced, then from here to this place, which is a constant velocity, and then deceleration, which it brought to rest at the zero velocity and at zero time.